In this section, we're going to continue talking about dividing polynomials, but I'm going to show you something called synthetic division, which I think makes dividing polynomials a lot faster than we did when we were using the long division method. And so synthetic division is just a shorthand method of dividing a polynomial by a linear binomial. So this only works for situations where you're dividing by something like x plus 2 or x minus 5, something in that form. So in order for synthetic division to work, your polynomial that you're dividing into must be written in standard form. And if there's any missing terms, you have to put a 0 in for its place. We did that a little bit with long division too, that we kind of had to hold values place with a 0 if it was missing. And like I said, the divisor must be in that form of x minus a number, or x plus a number. The one kind of big key thing to remember when you're doing synthetic division is there's going to be like two main parts to the problem. And there's going to be something that I refer to as the box. And so this is called, or I call it my box, I should say. It's not a full box, but it's just kind of like half of a square. And what goes in that is the number that you're trying to divide by. So you see how we have x plus 2 here? The 2 is the piece that I want to pull. But here's the thing to remember with synthetic division. You actually need to pull the opposite sign of 2. So right now it says plus 2. So into my box you need to put negative 2. That's really the only thing that you're going to have to change in this whole problem. Everything else is going to come from the polynomial. So you look at that, make sure that it's in standard form, which this one is because it goes x squared, x, and then your number. There's no missing pieces. So what we do is go ahead and just grab the coefficients. Those are the numbers that are sitting in front of your letters or just any numbers at the end. So you have a 2 in front of the x squared, a 7 in front of the x, and a 9 at the very end. Then you draw a line that goes underneath all three of those numbers. You always bring down the first number. You never do anything to that first number. So in this case, I'm just going to bring down the 2. And then what you do is you take this 2 and you multiply by the number in the box. So you multiply those two together, and that quantity is going to come right underneath the 7. So I'm going to take 2 times negative 2, which is going to give me negative 4. And that's going to go right here, under the 7. Then you need to add 7 and this negative 4. And that's going to give you 3. Then you repeat what we just did. You're going to take 3 times the negative 2 in the box, and you're going to put that number right underneath the 9. So 2, or negative 2 times 3 is negative 6. And then again we add 9 plus negative 6 is another 3. So right now we just see these numbers. What we need to do is write the polynomial that we just found using the 2, the 3, and the 3. So remember when we did long division that when we wrote our new polynomial up on top, I told you guys that it always started with an exponent 1 less than the polynomial that you were dividing by. So in this case, when it says 2x squared up here, your new polynomial that you found when you divided is going to be 1 less than that with your exponents. So instead of saying 2x squared, we're going to say 2, and then it's just going to be x, and then you have plus 3. Now this 3 here, a lot of times people will draw like a bar like this on that line to kind of remind them that that's your remainder. So remember, to write remainders, we put the number that's left, so 3, and we put that over what we divided by, x plus 2. So this is going to be your answer. Let's look at another one together. So I would again check right away that first big polynomial, see if there's anything missing. We have x to the 4th, x to the 3rd, and then it goes to x, so it does skip over the x squared term, so we will have to put a 0 in for that. So if it helps, I would just maybe put like 0x squared up here to kind of remind you of that. And then you have your x, and then you have your 1, so there's no other missing terms. Now what we're dividing by in this one is a -3. So remember, in the box, you need to change the sign. So right now it says -3, so we change it to +3 and put that in the box there. And now I grab my coefficients. So up here, x to the 4th has a 1, x to the 3rd has a -2. Make sure you watch your signs. Remember, we said there was no x squared, so I have to put a 0 in for that place value. 3 is in front of your x, and then you have a 1. And we're going to do the same thing that we did before. Bring down the 1. 1 times 3 is 3. And then I add -2 plus 3. I get another 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 in the box is 9. 3 plus 9 would be 12. 12 times 3 is going to be 36. Plus the 1 is going to be 37. And you're done. Remember, that last number there is your remainder. And you start one less than what you had to begin with in your problem. So we had x to the 4th, so we're going to start with x to the 3rd, 1x to the 3rd, 1x squared, plus 3x, plus 12, and then your remainder plus 37 over what you divided by up here from the top, x minus 3. Now, if in the very last box here, 37, if you get a 0 there, then this problem has no remainder, so you wouldn't have to add on. You would just end it at the 12. Alright, so why don't you guys give this one a try. Okay, so you should have put +8 up in your box. You've got m to the 4th, m to the 3rd, m squared, m, and then your 14. So it doesn't skip over any terms, so you should just be able to write out your coefficients like I have here. Bring down your first one. And then we begin our process. 1 times 8 is 8. -13 plus 8 is going to be -5. Times 8 is -40. Plus 33 is going to be negative 7, times 8 is negative 56, plus 55 is negative 1, times 8 is negative 8, plus 14 is 6. So our final answer should have said m to the third minus 5m squared minus 7m minus 1, and then plus your 6 over m minus 8. Alright, the last thing I want to show you guys is something called synthetic substitution. And we can kind of use this same process, this synthetic division process, to actually evaluate polynomials. So that would be the same thing as taking a value for x and plugging it in to all of the x's in your polynomial, typing that into your calculator, and evaluating it to get an answer, to kind of find like the coordinate that would be out there if we were looking at the graph of this shape. So when we use synthetic division, kind of that process to do this, we're actually looking for that remainder. We want to see what the number is that comes out in the remainder spot, and that tells us what the answer should be if I evaluated the polynomial for the specific value of x, or whatever letter they're using. So the difference between what we're going to do now and what we just did is, one, we're not looking for a whole polynomial. We're just looking for that one final number. But when you actually set up the problem, the number that goes in the box, you are not going to change its sign. So we're evaluating this polynomial, 2x squared plus 3x minus 4, for the value of 4. So we want to know what happens if I put 4 in for all the x's. And yes, of course, you could just stick 4 in for the x's and plug that into your calculator, like I said, but I'm going to show you how you can also use this synthetic substitution to do the exact same thing. So we take that 4, do not change the sign of that 4, put that in the box, grab your coefficients, still checking to make sure that nothing has been missed or skipped over. And right now what we're looking for is, like, what's the number that's going to come up here, because that's going to be my answer that I'm looking for. So I'm going to bring down my 2. We'll do the exact same process that we were just doing. So 2 times 4 is 8. 8 plus 3 is going to be 11. Times 4 is 44. And then add negative 4 to that, and you get 40. And so 40 is your answer. So if I took 4 and I plugged that in for those x's, so if I did 2 times 4 squared plus 3 times 4 minus 4, I should get 40. Okay, let's do this one together, and then I'll let you guys do the last one by yourself to practice. So I'm still putting in 4, so we put 4 in the box. Grabbing my polynomial here, just checking to make sure it doesn't skip over anything. We've got x to the third, x squared, and then my x. So I'm going to do 1, negative 4, 3, negative 5. Bring down the 1. And again, remember, we're looking for what shows up here. So bring down the 1. 1 times 4 is 4. 4 plus negative 4 is 0. 0 times 4 is 0. Plus that 3 is 3. So 4 times 3 is 12. 12 plus a negative 5 is 7. So 7 is our answer. Alright, you guys try that one. this is how you should have set up your problem. Bring down that first number, so negative 2. So negative 2 times 3 is going to be negative 6. Plus 3 is going to be negative 3. Times 3 is going to be negative 9, which is a 0. And then 0 times 3 is 0. So 7 plus 0 is 7. So our answer should have been